In part D, we have 8 divided by x squared minus 4 minus 3 divided by x plus 2. Okay, this one, there's a new step here. Notice what I do with these examples. I go easy, a little bit harder, a little bit harder, a little bit harder. So there's a difference here between this problem and the other problems. What do you notice about the denominator in the first term, 8 divided by x squared minus 4? Put more generally, x squared minus 4 factors. Look, in all the other examples, the denominators, you couldn't factor any more than they already were, right? They were already in factored form. And so because they were in factored form, it was easy to find the LCDs. In this one, the denominator, at least the left-hand denominator, is not factored all the way, unlike the other ones. So if we want to find the LCD, the moral of the story is we've got to factor all the denominators involved. Okay? Factor all the denominators. Well, okay, so just rewrite the problem. You guys know how to factor x squared minus 4. How does that factor? What formula do you use? Difference of 2 squares, so what do you get? X plus 2 times x minus 2. And then what about this second term, 3 divided by x plus 2? Is there anything you can do with that as far as factoring goes? No, remember, I didn't like that division bar. I don't think it matters, but remember, you have to think of the x plus 2 as just one quantity. In fact, it's a good idea to put parentheses around it. Okay? Factor first. This is all in the steps I have written below, so you don't need to write that down, but factor first, if necessary. This is the first example where it's necessary. Okay, and then you look at both sets of denominators, right? And then write down the LCD. Remember, the LCD has to contain, it has to be the smallest degree polynomial that contains all the factors of each and every denominator. So just go from left to right, like your grocery shopping. Oh, I need an x plus 2, right? I need an x minus 2. Then you go to the next denominator and say, oh, I need an x plus 2. I already have it. So I don't write it down again. Otherwise, it's not the least common denominator. Okay? Now, let me change something temporarily, so don't write this down. What if, so that was x minus 2. Okay, so what if, let's play what if for a second. What if you had a numerator in this one of 3? That's not the case, and I'm going to change it back in a second, but I want to make a point. If you went through that process, you wouldn't change the first part of that process. You would just look from left to right and say, oh, I need an x plus 2. Write it down. I need an x minus 2. Write it down. And then you would go to the next denominator and say, oh, I need an x plus 2 quantity cubed. You already have an x plus 2. What do you do, though? You need to take the higher power, don't you? We saw that in a previous example. So you would make this an exponent of 3. You wouldn't put in an x plus 2 quantity cubed separately as a factor. You would take the higher power of the two quantities, x plus 2s. Okay? So the LCD has to contain all the factors of each denominator, and it has to be the degree-wise the smallest polynomial that does that. Okay. Now that you have that, I think we can, as long as you leave yourself enough room here, I think we can go ahead and, oh, actually, I didn't need to move that one. I think we can go ahead and look at this denominator. It's good to go, isn't it? It contains both factors. What about this denominator? What is it missing from the LCD? So it's missing an x minus 2, so what do? Multiply numerator and denominator by x minus 2. The factor that it's missing from the LCD. Now, a lot of students get the bright idea of just saying, oh, I'm just going to multiply by x minus 2, and I know what I mean. I multiply that guy by... Okay, you may know what it means, but it's wrong mathematically, symbolically. Symbolism is important. Think about how important symbolism really is. Have you ever been talking to somebody, and they're saying one thing, but their body language is saying another? Yeah, symbolism is important. And if you don't develop the right symbolism now, even if you're not making mistakes now, you'll make mistakes later. So you don't want to just show that. You want to show what it is you're actually doing, which is multiplying numerator and denominator by x minus 2. Trust me, don't be lazy with the symbolism. It'll pay off later. Symbolism in mathematics is, we call it notation, and it's super duper important later on. If any of you have to go on and take calculus or statistics, symbolism is super important for understanding what you're doing. Another idea that I used to do when I was a young guy, I used to not write down the denominators until the very end sometimes. But you're in danger of forgetting the denominator if you do that. So show this work that I'm showing is what I'm asking you to do. Okay, so then if I wanted to write this as one big fraction, I could put in the big division bar, get x plus 2 times x minus 2. And then I have 8 minus 3 times this guy. I'm not going to show that. I'm not going to distribute yet. I'm going to write it like that. If you want to skip this step, that would be okay. But the reason I'm writing it like this is so that I don't forget to distribute the minus 3. Right? Okay, so what's the dark side here, you guys? Don't turn to the dark side. The dark side would be doing, don't write this down. Yeah, made it easier. Why is that not okay? Because of the minus right here. It's not a product in the numerator, is it? Can't do it. What can you do? Well, I kind of already indicated it, right? Distribute that minus 3. What do you get? Minus 3x plus 6 all over x plus 2 times x minus 2. Everybody agree with that? What do you think a common mistake here is when you distribute the minus 3? You forget the minus. You forget to distribute the minus on that guy and leave it as minus 6. Okay, combine like terms. What do you get? What's 8 plus 6? So you get 14 minus 3x or negative 3x plus 14 all over the LCD. There's no common factors in the numerator, so I'm just going to leave it as is.